this chapter, we will be looking at various types of functions. In this lesson, we're going to look at adding and subtracting functions.
All right, now this is an interesting topic because it really represents a step up in your math, okay? And it's exciting for me to discuss this with you guys here. This is what we're going to look at today is actually a very, very simple topic, really, what it boils down to. But it represents a significant change for you guys. In elementary school, you talk about numbers, and it's great. You add and subtract numbers and whatever, multiply, divide. You learn the operations. Then you transition over as you get older and you start to use variables, okay? Which is a little abstract, okay? We use a symbol to represent an unknown quantity. And you do math with the symbol the same way you were doing math with the numbers, right? And what you're doing is you're looking at the rules that stay the same here. Then you got to high school and you learned function notation. And what is happening here now is the function, this f of x, this notation here, f of x and g of x. Now, granted, they take on the y coordinate, and granted, in many cases, that's just a single value you're talking about. But in a broader sense here, what these represent here, these represent functions, okay? They represent something happening to the x coordinate, okay? They represent a rule that's being applied here. And so now, what we're going to do here is when they're defined over a given domain and when there's overlap in that domain, okay, because this is only, what I'm about to show you is only true. This is only true in the overlap of their domains. So these have both got to be defined. That's, my handwriting's terrible there. Okay. But when they're defined in a shared domain here, then when you add the two functions together, that is simply adding those two individual functions. And likewise, the difference between the two functions is really just the difference between the two functions here, the two dependent variables, or the y coordinates, if you will. We're not adding and subtracting x, the independent variable. We're adding and subtracting the resulting y coordinates. So this has a vertical impact on the graph, okay? Maybe we should identify that over here. This is simply vertical, both of these together. Not horizontal, we're not doing anything with the independent variable, it's just the dependent variables that we're getting here. But what's neat about this is we're starting to do arithmetic here, if you will, with functions, okay? With variables that no longer specifically represent like numbers per se, and yeah, you can argue that they do. But this is in a broader sense here. These are representing the rules here. And so what we're looking at here is the result when you add and subtract rules that are applied to the independent variable. This is really cool. So we're going to walk through some examples here right away.
For each of the following pairs of functions, determine the following. Given f of x is equal to 2x plus 7 and g of x is equal to 5x minus 11, find h of x, which is equal to f of x plus g of x.
Okay, so in this question here, to get h of x, we are adding those two functions together. And what's beautiful about this particular topic here is that even if I didn't go through and explain to you what's going on here, I think most of you would get it. You would know exactly what you're going to do here. I'm going to add f of x. And then I'm going to add g of x. Now, I put parentheses around both of these first because this represents all of f of x. So I put parentheses around the expression that is f of x. I put parentheses around the expression that is g of x. Now when it comes to addition, I really didn't need those, but because I do need them for subtraction, I want to use them right here. Now when I drop the parentheses here, I'm going to get 2x plus 5x, or 7x. Then I'm going to get 7 minus 11, or negative 4. And so that right there represents the sum of those two functions.
Given f of x is x squared plus x plus 8, and g of x is 2x squared minus 3x, find h of x, which is equal to f of x minus g of x.
All right. Now in this case, we're looking for the difference between the two functions that we're given here. And now in this case, putting stuff in parentheses is going to make a difference. If I don't put stuff in parentheses, I am very likely to do something like this. Okay? So now, if you're looking at this going, well, gee, what's wrong with that? Well, this is what's wrong with it. What am I subtracting here out of g of x? Well, now you might think, well, I'm subtracting both of them. It's all good. I'm subtracting. It says to subtract, I'm subtracting. But actually, you're not. This was negative 3x to begin with. If I subtract a negative 3x, that should have become positive. The only part of this that I'm actually subtracting is that first term. So in order to make it so that I'm actually subtracting g of x, I need to put parentheses around g of x, so that that negative gets distributed all the way through this expression here, okay? And that's what I want. If I don't distribute it through, then I'm only subtracting essentially just that first term here. Now, let's put these together. X squared is going to be grouped together with this one, but it's going to be negative. So x squared minus 2x squared, negative x squared. X minus negative 3x will be 4x. 8. Okay, well, there is nothing to compare with or to combine with 8. There's no like terms that are just constants, so I'm just left with 8. And that's the difference between those two functions.
Given f of x is equal to 3x minus 7 and g of x is equal to x cubed, find h of x defined as g plus f of x.
Okay, so for this question, we're back to addition. Notice it's just a slightly different way of writing it, but essentially what this means is, again, we've got g of x, the function here, and I'm going to put that in parentheses, plus, and then in parentheses, I'm going to put f of x. Again, notice the order here is important. Okay. Now, for addition, order isn't important, but it is important for subtraction, so you might as well be leaving it in the proper order right here. Now, there are no like terms anywhere here, so when I drop the parentheses, I'm essentially just going to write x cubed plus 3x minus 7. It's probably the most straightforward one out of this group.
Given f of x is equal to 3x minus 7 and g of x is equal to x cubed, find k of x defined as g minus f of x.
All right, similar sort of question to the one that we just did here. Again, notice order is significant here. So g minus f, okay, so in parentheses here, there's g minus, and again, if I don't put parentheses here, then the only thing that I've actually subtracted is the 3x. Okay, and granted, I know it looks like I'm subtracting 7 here, but it wasn't 7 in the original, it was minus 7. So to subtract minus 7, that should become an addition here. That negative should distribute through. Please put parentheses around that to group that together so that I know to distribute that through. Now, there are no like terms here, but the only thing that I'm required to do is distribute that negative through. So this will become x cubed minus 3x, and now here's the plus 7 that I need. That's what we're looking for right there. Perfect.
In this next section, we're going to take a quick look at combining functions graphically.
All right, now another way that we're going to need you to be able to approach these questions is to do them via a sketch. So we're going to sketch the sum and difference between two functions here. Now, the way you do that is you simply add or subtract the y coordinates at each point. It actually probably makes better sense to say that at each value of x, at each different x coordinate, you're going to add the corresponding y coordinates. Remember, this is a vertical change in these graphs. This is a vertical summation of the two, not a horizontal one. So the domain of the combined function, formed by the sum or difference of two functions, is the domain common to the two individual functions. Okay, so essentially, I can't add two functions together if there's a spot where one function doesn't exist. And that should be kind of straightforward here. So the example that we're looking at down here is f of x, and notice f of x stops right here at 3. There's nothing beyond positive 3. G of x starts at, that's at 3. Starts at negative 5 and slides forward. It doesn't exist beyond here. I can't add these two functions together here at negative 6 because I don't have g. G doesn't even exist over here. Remember, this is just vertical lines. We're adding along the vertical lines. So this part of the domain doesn't exist, and neither does this part right here. So the domain which is common to both of those is going to be this domain here. Negative 5 is less than or equal to x, less than or equal to 3. Now, the way that we get h of x right here is simply by adding the y-coordinates. So take a quick look here. F of x is, in this case here, is just slightly under 3. It's like 2.9, let's say. But the x-coordinate here, the y-coordinate here is 0. Put those together, and that starts right there. Now, it's maybe a little bit harder to see what's going on until you get to here. Both of our functions crisscross here where the y-coordinate is 2. So the sum of the two functions is going to jump up to be 4. Okay? Our y-intercepts here, one of them is a little over 2, but this one here is a little bit under 2. In fact, it's a little bit, the distance that this function is below the 2 is bigger than the distance this one is above 2. So when you add them together, you're getting something that's a little bit less than 4. And then this one drops off to 0 when x is equal to 3, and the other one is up here. Okay, g is, again, a little bit less than 3. So when you add those together, you get a function that's a value that's a little bit less than 3. So this represents the sum of all the y-coordinates. Now, but we're going straight up. So like right here, it's the sum of this number and this number is this number right here. We're just going along straight lines with every value of x. That's how you do this. Now, if we're doing subtraction, then you just need to be concerned about the order that we're subtracting the two functions in. But you just carry it in order, and again, you just line up the two functions here, take the x-coordinate, find the difference, and plot it. That's all you got to do.
Using the functions f of x is 2x plus 1 and g of x is equal to x squared, determine the equation of h of x, which is equal to f plus g of x.
All right. So this question right here, the graph is already kind of done for us here, so we're going to kind of interpret what's going on by answering these questions. First of all, we're going to look at the sum of those two. We're told h of x is the sum of f of x and g of x. Well, here are two functions right here, 2x plus 1 and x squared. There are no like terms there, so when I add those together, I'm simply going to get h of x is going to equal x squared plus 2x plus 1. Now, I know that I haven't written those in the same order here, but now that I put those together, normally I would really obey the order there, but order doesn't matter for addition, and I do really want the higher degree term first. So I'm going to do it like this for right now because it's not going to make any difference here. 2x plus 1 has the domain, x is an element of the reals, and the range will be y is an element of the reals. G of x has the domain, x is an element of the reals. So notice that these are defined, both of them are defined over the entire coordinate plane, essentially, okay, for the domain there. The range for this one though is going to be y is greater than or equal to 0. Now, when you put those together, okay, okay, this graph right here, we start to get a little concerned here. Well, what's the vertex here? Okay, now, I'm sorry, I'm already anticipating the range here. The domain is going to be x as an element of the reals. Both of those functions are defined everywhere. Their sum is also going to be defined everywhere. Okay, this consists of all the values that are common to both the domains here. Now, the range. The graph here is designed to kind of help us out with this. This function right here represents the sum of those two. I'm tempted to believe that the range here is going to be greater than or equal to 0 here. However, I do have a tool, okay, that I learned back a year ago here called completing the square. Okay, so what I'm going to do here is I'm going to move that constant over. I'm going to complete the square to find the vertex just to make sure that there's no little detail in there that I'm not comfortable with. Half of 2 is 1, squared is going to be plus 1. I'm going to subtract 1 right away. I'm going to take that negative 1 out. So I'll take negative 1 plus 1, and then this is going to end up becoming x plus 1 squared, and outside there's nothing. It's going to be plus 0. So my vertex here is going to be negative 1 comma 0. My range is going to be y is greater than or equal to 0. So that is basically what I'm seeing in this graph here. That when I add those together, it's going to be greater than or equal to 0. Now, actually, I can defend that. When you add these together, this is the original parabola. Here's the original line here. Now, when you add them up here on the vertex, okay, the vertex is 0. This function here is at 1. So when you add those together, you're going to get 1 here. Now, as we go to the left of that point right here, the line drops down, but the parabola goes up. So the parabola adds a value the line subtracts a value. Now, when you go 1 to the left, the parabola's gone 1 up, the line has gone 1 down. So they're going to balance each other out. You're going to get a point there at negative 1, 0. But the further over you go to the left on the parabola, it rises much, much faster than the line drops. And so now, from this point on, the parabola is actually going to pull these values up. The line is trying to pull them down, but it's not quite strong enough to balance out the fact that these are large positive numbers. So the parabola is going to curve up. So that really is the lowest point there. Y is greater than or equal to 0.
Given the graphs of f of x and g of x, sketch the following. M of x is equal to f plus g of x.
Okay, so now we want to sketch the sum of these two given those two graphs there. Now what we're going to do is we're going to just pick x coordinates and add the y coordinates. So, and this is nicely done because all these dots are kind of laid out for us. So let's start over here at the left side here, and I've got when x is equal to negative 4, this value right here, f right here is at negative 3, g is at 1, negative 3 plus 1 is negative 2. Move over, f is negative 2, g is 0, add those together, I'm going to get negative 2. Move over here, for f, the y-coordinate is negative 1, for g, the y-coordinate is negative 1, add those together, I'm getting negative 2. Now I'm starting to see a bit of a pattern developing here. In this case right here, f is going to be 0, g is negative 2, add those together, you're going to get negative 2. Yeah, that's looking pretty consistent. F is at 1, g is at negative 3, add those together, we're going to get negative 2. Yeah. Okay, I'm not going to do this anymore because I can tell this is just going to do this. So the line that we're going to get here is this line, y equals negative 2. That's going to be the sum of those two functions here. Now I can make it look like I did all of those by putting those dots there, but I think it's pretty clear what's going to happen when you add those two functions together.
M of x is equal to f minus g of x.
Now the previous question, the graph ended up being kind of boring there. Let's see what happens here. Now I'm subtracting the two, so now I really have to pay attention, very close attention to order. So here's f, and when we start over here at negative 4, I get a y-coordinate of negative 3. Okay, so negative 3, the y-coordinate here is 1, negative 3 minus 1 is negative 4. Then I come over here. The y-coordinate is negative 2, minus 0 is going to be negative 2. Okay, right now that's already a little bit more interesting. The y-coordinate here for f of x is negative 1. It's also for g of x, so negative 1 minus negative 1 is going to be 0. Here, f is going to be 0, g is negative 2. 0 minus negative 2 is going to be 2. Here, the y-coordinate is 1. Here, the y-coordinate is negative 3. 1 minus negative 3 is going to be 4. Here, the y-coordinate is 2. And remember, just to say this again, I got to start with f because f comes first. So this is going to be positive 2 minus negative 4 is going to be up at 6. And I can see already that I'm off the grid here. Okay? So now, just because I can see this is going to be a straight line, I want to make this nice and pretty. I'm going to connect those dots there. And this represents m of x right there. The difference between those two functions.
Consider f of x is equal to x squared minus 7 and g of x is equal to 4x plus 5. Determine the following. H of x equals f of x plus g of x, and then find h at 2.
Okay, now to answer this question, I'm going to do this in two different ways here. First of all, I'm going to do it like this. I'm going to take the two functions here, x squared minus 7, and I'm going to add 4x plus 5. I put parentheses around both of those. Now I'm going to drop the parentheses and group together like terms. So I'm going to get x squared here because there's nothing common with it. There's a 4x here. Well, there's nothing, no other term that's common to it. Then I've got a negative 7 and a 5 here, so that's going to be negative 2. So here's my h of x, h of x. Now what I'll do here is evaluate h of 2, and that's going to get me 2 squared plus 4 times 2 minus 2. Okay, well 2 squared is 4. 4 times 2 is 8, so 4 and 8 is 12, minus 2 is 10. Now that's one way that we could do this. Another way that we could do this is to understand that h of 2 because h is the sum of those two, is going to be f of 2 plus g of 2. Well, I don't know why I wrote it like that. I wanted to put an x there. 2. Now, with that in mind, I can go back up to here, plug 2 into this. Well, what's f of 2 here? Well, 2 squared is going to be 4. 4 minus 7 is negative 3. So f of 2 is negative, oops. Man, that's just odd. Why did I do that? Negative 3. G of 2 is 4 times 2 is going to be 8, plus 5 will be 13. And when you add those together, you get 10. So you can either find the function that represents the sum of those two, or you can just sum the two functions. Either way works just fine.
M of x is equal to f of x minus g of x, and then find m at 1.
All right, now we're going to answer this one similar to the one that we just did. I'll do it in two different ways here. So first of all, we're going to take and create the function that is the difference between these two. Remembering order is important here. So I put parentheses around the two functions so that I understand that I am subtracting all of g and not just inadvertently part of it. And when you distribute the negative through here, now there is no term that's common with the x squared. There's no term that's common with the linear term here either. It's just going to be minus 4x. But now I'm going to get negative 7 minus 5, which will be negative 12. And now m evaluated at 1 is going to be 1 squared minus 4 times 1 minus 12. So 1 minus 4 is negative 3, minus 12, negative 15. And that is one way to do it. The other way to do it is going to be to say, okay, m of 1 is going to be f of 1 minus g of 1. Now I got to go back to my definitions here. F of 1, okay, f of 1. 1 squared minus 7, okay, that's going to be negative 6. G of 1. Okay, 4 times 1 is 4, plus 5 is 9, so minus 9, and the answer is negative 15. So it really shouldn't matter what order you do those in. Now, again, it matters what order you subtract them in, but it really shouldn't matter whether you evaluate the functions first or you evaluate you evaluate the function at a specific point later. That shouldn't matter.
Use the graphs of f of x and g of x to evaluate each of the following.
Okay, I like this question. I like the way these questions work here. So we're just going to run through this really, really quickly here. We're going to use this graph here to evaluate these summations here. So f plus g at negative 5. Now, all I really got to do here is when I'm going through this is just bear in mind which of these functions is f, which one is g. F is the darker one, g is the lighter absolute value. So at negative 5 here, this means x is negative 5, f is 3, okay, g is 6. So this is going to be 3 plus 6, or 9. So f plus g evaluated at negative 5 is going to be 9. Now, f minus g at 3. Now that means the x coordinate is going to be 3. So I come over here to 3. F is the dark one, so f at 3 is 1. Minus g of 3. Okay, well g of 3 is the absolute value here. So g of 3 is going to be 2. So 1 minus 2, the answer is negative 1. F minus g of 3 is going to be negative 1. F plus g of 5 is going to be f at 5. Okay, well, f doesn't exist out there. F stops at 4. I can't do that question. That's a meaningless question to me because f doesn't even exist out there. I can't add it if it's not there. So, no answer. You just move on. G minus f of 0. Okay, so now I got to start with g here. G is the absolute value, and g at 0 is going to be 1. Minus f of 0, the darker one here, is going to be 2. So 1 minus 2, we're looking at negative 1 again. And that's how you read these things off here. You take your clue from the x coordinate that you're given here, in parentheses, and then you go look for the y coordinates, and then you just apply that operation, but to the y coordinates, not to the x coordinates.
Suppose that h of x is equal to f plus g of x, which is equal to 7x plus 15, and that f of x is equal to 2x plus 1. Find g of x.
So I really like this question here because it does illustrate how the math that we apply to functions is very, very similar in many ways to just regular arithmetic or algebra work here that we would do. For example, if we know that h of x is equal to f plus g, and the result is 7x plus 15, and we know what f is, how do we get g? Well, if h is equal to f plus g, it's probably quite clear, okay, even from just this right here, that h minus f is equal to g. So in this case here, g of x is going to be h of x minus f of x. Okay, so we're going to get 7x plus 15. And I'm going to put that in parentheses there because that's h of x. F of x is 2x plus 1. So we're going to put that in parentheses. Okay, because the whole thing here is 2x plus 1. And now when we drop the parentheses, I'll distribute the negative through. So 7x minus 2x is going to be 5x. 15 minus 1 will be 14. So g of x is going to be 5x plus 14. It's very intuitive.
Suppose h of x is equal to f minus g of x, which is equal to 6x minus 8, and that g of x is equal to 3x plus 5. Find f of x.
And so this question here is very similar to the one that we just did. It's just structured a little differently because we've got a subtraction here. If we know that h is equal to f minus g, okay, and we know what that function is and we know what g is, to get f, I'm simply going to add g to both sides. So h plus g is going to equal to f. So f of x is going to equal to h, and I'll put this in parentheses here, 6x minus 8, plus g is going to be 3x plus 5. Okay, and again, I put parentheses around those things so that I realize that it's all of h plus all of g. And now when I drop the parentheses, 6x plus 3x will be 9x. Negative 8 plus 5 will be negative 3. And so there's my expression for f of x.
Given the functions f of x equals 4x squared minus 3, and g of x is equal to the square root of x minus 8, write a simplified equation for each combined function.
Okay, so for this one right here, we're just going to practice what we already know here. So we've got our two expressions here for f of x and g of x here. So our first one here tells us to add the two together. So again, I'm going to put parentheses around my f of x, and I'm going to add, and I'll put parentheses around my g of x. And then I'm going to drop my parentheses here, but that's simply going to give me 4x squared minus 3 plus the square root of x minus 8. There's really not much I can do to simplify this. That is about as good as that's going to get. Over here, if we've got f minus g of x, okay, again, this is going to be f of x, all in parentheses here, minus, and we'll put g in parentheses as well here, but there's only a single term here in g, and so when I drop those parentheses there, it's really just going to look like this. 4x squared minus 3 minus the square root of x minus 8. Now, maybe I should put those in a slightly different order, maybe make it 4x squared minus the square root of x minus 8 and then put a minus 3 at the end, but there's really nothing wrong with the way that sits right there as well here. This g minus f of x, okay, this is going to be slightly different because we've changed the order here. So in parentheses, there's my g of x minus, and again in parentheses, here's my f of x. And in this case here, that set of parentheses is actually quite important because when I drop it and we distribute the negative through, okay, when I'm subtracting that negative 3, I have to let that become plus 3. And there again, there's nothing wrong with necessarily writing it like this. You might want to push the radical to the back or to the middle or wherever. It doesn't really matter. Order at that point doesn't really make a difference. The issue here, what's most important, is that we're distributing that negative through those parentheses. It wasn't necessary in the previous one because it was just a single term, but it is necessary here.
If h of x is equal to f of x minus g of x, where h of x is the square root of 3x plus 1 minus x squared plus 4, and f of x is the square root of 3x plus 1, what is g of x?
Okay, now this question is similar to one that we did a couple questions ago here. Again, I know that h is equal to f minus g. We're told what h is, and we want to figure out what, we're told f is as well, and we want to figure out what g is. Well, what I might do here, a little bit of algebra, I might add g to this, to the left-hand side first, so h plus g is equal to f, and then make this g is equal to f minus h. Okay, so there's my expression for g here. Now I'll plug that in. G of x is now going to equal f of x, and I'll put this in parentheses, 3x plus 1, minus, and then again in parentheses here, and I'll put h of x, which will be square root of 3x plus 1, minus x squared plus 4. Okay, now it's important that because there are multiple terms in that h of x, okay, that whole thing's got to be in parentheses so that that negative can distribute to every term here. Okay, basically, remember, I'm subtracting all of h of x, not just that first piece. And so now when I distribute that negative through, I will get negative the square root of x, 3x plus 1, plus x squared minus 4. And now the square root of 3x plus 1 minus the square root of 3x plus 1, those are going to cancel, and I'm going to be left with x squared minus 4 as my value, or as my expression for g of x. That's what we're looking for.